And that actually also works with nice block. I'm showing you a nice block because that's the only example I have in mind that has an unstructured counterpart, which is what I'm going to show you after that. I'm a lot into cooking, so that also makes a lot of sense to me. So, right, you have a set of knives. They go into just one right place, and it's not like you can fit anything else than a knife. I mean, you could probably fit a fork in there, but that wouldn't really work. And then you have some things like this. That's a universal knife block. So you can store anything, right? You can store any kind of shape of knife in any places. You could probably store anything else than a knife. That's what I call unstructured data. You can store pretty much anything. There's no schema, there's no column, no types. It's not like you can do anything. It's schema-less. It's something, it's a keyword that you hear a lot about in the NoSQL space. Everybody says, oh, with schema-less, you can store anything you want, which is great. I mean, storing unstructured data, lots of liberty. You can, flex the thing, and then, if you have too much liberty and you don't take care of what you're doing, then you might have a problem, flexibility problem. So that's basically what I'm going to talk about today, is how do you avoid this kind of situation, which is, something bad could happen. This is the outline, or at least the set of questions that if you need to go out of this talk with just one slide, that's probably this one. It's all the questions you need to ask yourself to make sure you're going to structure or have some sort of structure in your structured data. You need to look at how much data you're going to write or read, like the ratio. Is it writing more important than reading? You need to think about the architecture of your store. Is it distributed? Is there consistency? How is consistency handled? And what tools it gives you to retrieve that data. I mean, from a nice block perspective, I know pretty much when I'm going to get one knife out of there that it's going to be the one I'm looking for. If everything is hidden under an unstructured store, you have no idea what's going to happen. So you need to know how to retrieve that data, and that's maybe a key value get based on the ID, the key. Maybe you can do queries with materialized view. Maybe you can do ad hoc querying like SQL. So all of these are the questions you need to ask yourself when you think about data modeling. And of course, there's the domain design part, which is, I'm not going to talk about it today because that's completely based on the application you're doing. I cannot give you any advice based on your domain or business code because I have no idea what you're working on. I mean, can give you some guidelines, but it's really about guidelines. So I'm going to first explain what is a key value store, or what do I hear about key value, and then about documents. So key value store, you have a key, that's the email, and you have something, anything. Here it's just a string. You could have a JSON string that now would have like more semi-structured data. Like there's an implicit schema in there. Like there's a field, it has a type, it's a string, because JSON is types. There's type, numbers, null, and it has a inner column name. That's what I call semi-structured data, and that's something you can do with key value store. Could really be anything. Could be a binary image. Whatever. The important bit about that is the only thing you're going to be able to use is the key, because you have no idea what's going to be in the value. Even if you're storing semi-structured data, if it's just a key value store and you have no way of querying anything except the key, then you need to be extremely careful about the key. Now, what do I hear about document store? A document store, usually it's storing semi-structured data. What you might have heard before document store of the term object database or object store. There was something like Berkeley DB. It was an XML database. It's a bit of the same thing, and it's been popularized roughly 10 years ago by CouchDB and MongoDB because it was storing JSON, and everybody was writing JSON code at the time, so it felt like a good thing, like you're using a JSON store, and it's a native data structure for JavaScript. So that's why it became more and more popular, and that's probably why JSON store worked much better than XML store. Oops. So here's a couple of things you can do with a document store. What I will define as document store is being able to query things based on the content of the many documents. So you can get the list of all the people that are based in London. You can get the list of all the people that are doing developer advocacy, because you know that in your user JSON document you probably have a field with the location, have a field with the job. So you can retrieve several documents at a time based on the content of that document, and that's what makes a a key value store, I mean, at least an unstructured store, going to a document database is the ability to retrieve some meaningful data based on not only the key anymore, but the content of the document. So you can do join and you can even mash things up, just like you do with SQL. So that was just a quick introduction about what I think is a key value store and what's a document store. Any questions so far? All right? No? Cool. We're going to get more in details into data modeling for key value. So key value store is great for two things. More, but at least those two things are what most of our customers are doing. It's great to pre-compute answer asynchronously. I'm going to explain that more into detail after that. And to store object state. Think about caching user session. When you log into the Apple Store and you have your login and your password, the session, the Apple session is actually stored into Couchbase. We store a lot of user session. So when you use a key value store, there's really two things you need to ask yourself or think about. Choose when you embed and refer your data. That's normalizing versus denormalizing data. And learn how to model your keys well, because then you just have keys. You don't have any query language. You are stuck with keys. So you need to make sure that with your keys, just with your keys, you'll be able to retrieve the data you want. That's the important bit. So what do I mean by pre-computed answer? If you look at the SQL world, it's fully normalized. You have tables, you have columns. And when you have a store like this with table and columns, you have a predefined list of questions you know you're going to be able to ask based on the name of the column or the type, which is exactly what you have in this game. You know that if you did the job well and everything is normalized, you'll be able to ask any question you want based on the model you have. Which is great, right? As a developer, if you do your job well, you feel safe. You know that you'll be able to ask anything you want to the database, whatever you're going to ask, as long as it's nicely modeled. It's not the case on a key value unstructured store. If you don't know what you're storing or how you're storing it, and you don't model your keys right, then you have no way of knowing what you can ask in advance. In the SQL world, you know because you have type, you have com, you have a schema. So you feel safe. In the NoSQL world, you can think of it very much like a library. If I go into a library and I search for the book The Theory of Evolution by Darwin, I know I will find the first original book, like the thing that explains everything. That might be a bit boring if I'm a teacher and I'm going to explain that to someone. I'm probably going to use a book for kids that show everything in a different context, and its context is the keyword. In NoSQL database, when you're storing something, it's really based on the context. There's a very intelligent person, Martin Fowler. He works at ThoughtWorks, and he has been writing a lot of books about NoSQL. And when he talks about NoSQL store, he used the term aggregate data. An object like this, it's an order, an e-commerce order, or any real commerce order. You're aggregating all the things you need in one place. If you think about the SQL side of things, you will have a table with the orders, you will have a table with the customers, you will have a table with each order lines, the credit cards, and everything. So when you want to get that data in the SQL world, you need to query everything, aggregate everything back on the application layer, because it gives you an answer, probably some rows, JDBC rows. You get those objects, you map it to a Java structure, and then you aggregate everything, and then you send that object to the client. So it's really aggregating all the information you need at the same place. That takes some time. If everything is splitted across several tables, or first you have to think about how you're going to do your query, which is a bit painful. I mean, we're all used to that. We're all used to SQL, so that works fine. But then, if it could be faster, that'd be great. And that's one of the reasons why people would use aggregate data store on the SQL unstructured data store, and that's what you have here. So when I talk about pre-computed asynchronous answer, we have a customer called Skyscanner, but maybe you've heard about. It's it's a website to get flights when you travel a lot. And what they do is when you want to display one page from Skyscanner, this page, there has to be lots of call of many different APIs, many different providers everywhere in many, many websites. And they're not going to do that all the time because it's extremely costly, right? So what they're doing is to all these calls, aggregate everything into one single document, and then cache this, and then when you do this search again, they will display, they will get the answer at just one place, which is the aggregate JSON document that you created based on all these API calls that you don't have to do again because you've created. Of course, you will have to do it again because this information are cached and will need to be updated at one point, but not all the time. You don't want to do all these things all the time. So if you think about a cache use case, aggregates like this works very well. So when I talk about aggregating, if you think about it, that probably means that you're gonna maybe duplicate stuff. If you think about SQL, everything's normalized, you never duplicate something, so you never have any consistency issues or anything. When you start duplicating content, then you might end up having consistency issues. So maybe you're thinking, maybe I should not embed the data all the time, I should not aggregate everything all the time, which is a legitimate question to ask yourself, is when do I embed and when do I keep on normalizing stuff like in SQL, when do I refer to data? That's the traditional SQL example. We have a product table, we have customers, orders, order details. I'm going to go very quick on this. You all know what it is. It's SQL. That's the aggregate version. That's just one single JSON document that contains everything into one place. But most of this data, they live into other documents because there's the reference of the document. I'm creating an order object for one user, and here I'm embedding all the products they've used. Right now there's just one product, it's a red Couchbase t-shirt. That product probably exists in another document, and that's the reference, right? So you're duplicating stuff. If I change the description of the product, in SQL I will change it in just one place, because it's normalized. Here I would have to change it at the reference place, right? And I would have to change it everywhere I've embedded it, which no one wants to do that because it's painful and you might forget some stuff. So that's when you will think I should probably refer to that data, and instead of having everything at the same place, I should probably start splitting things, which is normalizing, just like you would do with SQL. So now I have the product object. There used to be the product JSON file embedded inside it. Now I just have the ID, so I'm referring to that object. It's just like a foreign key in SQL, really. It's the same thing. Just referring to another object based on that ID. So I still haven't answered that question. When do you embed, when do you refer? Well, the most important thing when embedding data is speed. If we talk about aggregating data, you think about aggregating data based on what you want to do. If you're working at Skyscanner, you want to display extremely fast the response of the search that the user did, right? So in that case, that makes sense to cache everything and to aggregate everything because it's so costly to query all these API and services again. So you can embed data when you are not sure, but at least reasonably at ease with the fact that you will have some duplicated data and you know how to manage it from an application perspective. That requires that your data won't move too much, which means you won't have to update that data too much because, again, if it's duplicated, that's a lot of work to make sure that you haven't forgotten any place where it's been duplicating, so you need to think about it. And as a NoSQL is a very dumb thing, on a contrary to a SQL database, a NoSQL database just stores stuff. A SQL database will do many other things. They will handle transaction, they will handle the search for you, all this kind of stuff. You cannot do this with just a key value store, so a lot of the logic will go back to the application layer, so you need to be confident that you'll be able to manage all these things that were managed by the SQL database in the application layer, which most of the time is quite easy. It's just that instead of doing it in the SQL database, you will do it on the application side of things. So when should you refer? Well, pretty much in every other use case where you don't need speed that much. Couchbase is a consistent, extremely consistent store. So I'm not here to talk about the architecture of Couchbase, but basically, Couchbase is a read your own write store. When you write something, it's consistent hashing, so we will do a hash of the key. That key hash, we know exactly on which node of the cluster it's going to be. So with one key, you always write or read at the same place, so it's strongly consistent. In some other store, if you store data and you write data and you do a read again, well, that read might do another query and might not go at the same place, so you might have stale data because it's not strongly consistent. Couchbase, because of consistent hashing, is strongly consistent. So if it's strongly consistent, what we would tell you is, if speed is not the mandatory thing for you, we think you should refer most of the time. The other obvious use case, if you're aggregating something that's going to grow indefinitely, then you're going to have a huge document, huge JSON document, and no one wants to have more than 20 megabytes document go into the network. That's stupid. Don't do that. So if you're doing a chat application and you say, oh, what a good idea, I'm going to store all the conversation into one single document, no. So about key design, which is, again, if you're on a strict key value store, you have no way of querying anything. The only information you have to retrieve your document is the key. The key is the key, which sounds extremely weird. There's three kind of pattern, usual pattern. There's you can use a human readable key, or at least deterministic key. It's a key that you know will be able to retrieve or to rework when you need it. You can use computer generated keys, and then you can do compound keys, which is a mash mix of the two. So, human readable or deterministic key. You're storing a user document. Now, a user could have a very complicated UID. You could also use his email because you know that one email is associated probably to one person in the world. So it sort of makes sense to use it as a key. And it's a key that you can retrieve. You all know the forgot your password function, right? In a website, I've forgotten my password. You're not expecting people to remember the UID of the user, right? They can't, but they remember their email. So if you use the email as a key, then it's extremely easy to retrieve the right document. So that's what we would think about when saying human readable or deterministic key. And there's way too animation in that slide. Random computer or generated key. Think about a primary key field, with auto increment, just a counter. So instead of using the email, I could use a user counter that's incremented each time you create a new user. I think that's pretty easy to understand. An interesting pattern you can do with this is lookup documents. A lookup document is like a manual index. So if you still want to create that user with a random or computer-generated key, for various reasons, you can keep on using a counter, right? So here, the first thing I do is get the user ID by calling the increment method on the counter object. So I get a new counter value. Now I can create my new user using that counter value. And what I'm going to do is create another document. The key of that other document will be what was the deterministic part, the user email, and the value of that document will be the counter. Now, what does that give you? If you, as a user, still want to retrieve your account because you forgot your password, you're going to enter your email address. What's going to happen under the hood is we have your email address. There's a document that has your email address as a key and has the actual document ID as value. So we're going to do two key value gets. One with the email, we have the ID, one with the ID to get the actual object. That's just like manual indexing. This is extremely fast and will always be faster than doing queries on any system. In Couchbase, everything is stored in memory, so when you do a key get, with consistent hashing, we know which node to ask, and since everything is in memory, basically we just do one network trip and get the answer back. So that's under the millisecond, it's microsecond time, which is extremely fast. If you do a query on a distributed system, well, if you do a query on a SQL database and you don't have any cache or anything, you would have to scan everything to get the right thing, so it takes a bit of time. If you do a query on a distributed system, usually there's a round robin that chooses one node. The node will scatter the query on every other node. That takes some time. scan everything, retrieve the data, and then send you the data back. So doing 2 key value might sound like something, wasteful. You're doing 2 queries instead of 1, but that's actually much, much faster to do 2, 3, 4, 50, even 200. We have some customers that have like 200 document lookup keys. So 200 gets will be faster than most of the queries you want to do. So that's something to keep in mind. Even if you use a document store with many crazy ways of querying data, at heart, a key value store will always be faster if you use the key value part. Lookup document is something extremely cool and extremely important. It's just like manual indexing. It is really nice. Now let's talk, so you can have multiple lookup documents. You don't have to have just one. You can have one based on the email, one of basically everything that's human readable or that you can, that is deterministic. You should be able to use it as a lookup document. And then there's what we call compound keys, which is basically a mix of having a predictable name and a counter, or generated ID. If I take my user example again, oops, you can see there's a product view array. So I'm embedding the product views, but then this is going to grow its product view. So it's going to keep on, hopefully it's going to keep on going to your website, and it's going to keep on view some products. So this is going to grow indefinitely. So what you can do is create a new key based on what was the name of the field and the ID of the user. So each time you have a user, when you want to retrieve the product, all you have to do is get the user key and then append what was the name of the field. And that gives you the idea of a new document, and then you can add more and more stuff in that document. It won't make your original document grow indefinitely. And of course, you can apply that to many other things. So if I have a product list called 8, I know that all my products are stored with P as product and the ID of the product. So I know that with that document, I'll be able to retrieve everything without doing any queries, because I know how I've designed my keys. I know how to get stuff based on that. That was just for the key value part. Now the views. In SQL, in the SQL database, a view usually is another way of seeing the data in your table and columns. You're basically rebuilding an index, and that's what people refer to as materialized views. In Couchbase, before our new query language, that I'm going to talk a bit after that, most of the work in a normal application, 90% of that work was done by key value. And what you need to remember about key value is that I'm doing a key, I'm getting just one object. If I want to do range query or get all the user, I don't have an index. I mean, if I want to get all the user, if I know the value of the counter, I can retrieve the actual value and then do a bulk get of all the IDs I've created based on the counter value. That's quite wasteful, to be honest. So this is some time when we will ask you to consider using views. A view is like a materialized index. So in the Couchbase world, or if you have heard of or used CouchDB, a view is created using what we call an incremental map reuse. Who's heard of MapReduce before? Or who hasn't heard of MapReduce before? So you all know what MapReduce is, which is nice because I don't have to explain it. Basically, each document mutation goes into Couchbase, goes into every MapReduce function you have defined, and inside that map function, you can add one or several entries to an index. And once you have an index, of course, you can query that index, which is why you could use views, and it was useful to use views. So it has several roles. As I said before, if you want to get every user, you would have to get the counter, create every keys based on that counter. A bit counterproductive. If you have views based on that, each time you get a document that has a field called type and the value is user, then you can add an entry to that index, and that gives you a secondary index that contains all the user. So it's really about, just like in the SQL world, having a different materialized views based on your data. What's nice with the MapReduce function is that you don't have to just emit the ID of the document in the index. You can actually do some computation, do some fun stuff, and then have the exact value you want in the index. So if you just use the ID when you do a view query, you get the result, which is a list of IDs. So if you want to display the details, then you have that list of keys, and then you need to query all that key again. which is quite wasteful. If you did the job right, and if you don't want to show many stuff, you just want to show, for instance, the title, instead of using the ID as value, you would probably just use the title. When you do a query, you will retrieve that title, so it will let you avoid to query every single document to get that title back. So you need to think about it too. Here are some map reuse examples. Just a JavaScript function that runs on the server side, takes a document and the metadata of that document, and then based on that you can add an entry into one index. It's pretty simple, really. What you can do once you have your index, well, you can do queries. Once you can do query, you can do exact match query, you can do range query, but if you use the date as key of your index, then you can do range queries, every document created between this date and this date. If you're also using dates, you can do group by, which is group by months or days or whatever you want. I mean, it's the classic thing you're expecting from being able to do a query. But the thing is, if you want to do that query, well, you need to think about it first. In the SQL world, in a world where you know that you'll be able to ask anything based on the table and the columns, you don't have to do that. Just run your query and you'll get your response. Here with the views, you need to actually create that view, materialize that index. You need to think about it before, basically. That's a bunch of best practices that I'll leave here in the slides, and you can probably check it out later if you want to. So what happens when you want to do a query that you didn't think about first? That's what we call ad hoc querying. It's what SQL does. It's about being able to ask anything to an unstructured data store. When you ask anything to a structured data store, that's fine. You have table, you have columns, you know what you're going to ask. I said that several times, and I will say that again. In an unstructured data store, you have an implicit schema based on the name of the field you have in your JSON document. So, unless you parse every single document in your database, then maybe you could generate a schema, and maybe you can do the same thing. But the cool thing is, with Couchbase, we can do this very unspectacular thing, which is write that SQL NC92, basic SQL. Select star from travel sample, where type of document is airline and country is United Kingdom. And the good thing is, it gives you the answer right. It's just give you a JSON answer. If you're doing JavaScript, that's great, because you don't have to map anything. You just get that data out of the database. You don't even have to select star. You could select just the field you need, and then you will have your objects ready to be used directly into your application without having to do any kind of mapping or anything like this. So it's actually quite fast, and the good thing is, it allows you to use the implicit schema that's inside your semi-structured document or unstructured document, which wasn't the case before. I think that's, it's pretty cool. You should be more excited about that. It's SQL queries for unstructured data. Yeah, so that's just a table to show you that we got the best of both worlds. So that's the marketing part of the talk. That's great, we rule. You get the unstructured flexibility of an unstructured data store, and then you get the power, the querying power that you would have with an SQL store, which is, again, one thing quite cool and amazing. Yeah, both for both worlds. Best thing of both worlds, sorry. So, nickel features from SQL. I'm going to go very fast on this because you all know SQL, right? So that should be familiar with you. It's SQL NC92. It's a superset of SQL NC92. So all the things you use in SQL NC92, it's there. Which also means we have a nice JDBC driver, ODBC driver. So it's pretty cool. You can do joins. We are the only NoSQL store that allows you to do join natively without adding any other modules. Like most of the people would tell you to use Hadoop or Spark and then Drill or all these fancy extremely cool languages, which are all very nice, but then you don't have to deploy, what's the name? This scary stuff. I know Yarn, but Yarn is based on something. Zookeeper. You don't have to use Zookeeper just to do a query. I don't know if every one of you has used Zookeeper before. It's just the most painful thing to set up. Yarn is a bit better, but still. And that's something you need to use when you do Hadoop or Spark stuff. And with that, you can do join without having to care about anything like this. You just have to install Couchbase, which is great. So Couchbase 4.0 was out like 2 months ago. We only support in production select. Couchbase 4.1 will come out. It's already in developer preview, actually, on beta. I think it's in beta. So you can download it and you can try the new features, which are update, delete, insert. Just like something you would expect from an SQL store, but based on an unstructured JSON store. So I'm gonna, all right, that's the important bit too. It's SQL, so when you do a query, you can ask for a query plan. And once you have your query plan, you know where you can add index. We have different type of index. We're going to keep on adding indexes as we go. But it is really like SQL. I'm gonna go a bit faster and then tell you about the cool extension we have for JSON document. So first, we are at heart a keys value store. So when you do a query, instead of using the content of the documents, you might as well just use the keys. If you did your data modeling right, and if you know how to generate your keys based on your data modeling, then you can use keys directly, and it's going to be much faster than doing an actual query. It will use the key value capability of Couchbase to answer much more faster. And you can do joins. So right now, joins are only available on keys. So if you have a document called, I don't know, airline, because our sample in the new version of Couchbase is a travel sample, so there's airline, planes, all this kind of stuff. You'll be able to do a join based on the airline ID and the key of another document that is that airline ID. Okay? So if you have one travel example, in that travel example, you have the airline ID, there's an airline document somewhere, and the key of that airline document is the airline ID in that document, then you can do a join. In the future version of Couchbase, you'll be able to do joins based on anything, which hopefully will come out soon enough. Nest and a nest, two important keywords. We are using JSON documents. When you think about most of the SQL store, the data type of your columns are usually Scala data type, just a simple string. There's no list or anything. I mean, it could be, but most of the time it's not. In a JSON document, you could have arrays, you could have objects, you could have arrays of objects, object of arrays of objects, you know, all these things. So if you have an array, for instance, you want to flatten that array, you can use the unnest keywords that will flatten that array and allows you to do join based on, you know, that array. Like if I go back to my product view array, I would have an array of IDs, so I could unnest that array and have a simple. I should probably add an example at one point because it's better to see it written, which I don't have, unfortunately. So it puts everything on the same level, and you can do a join, and you can have an answer with the product embedded directly in the document, just like if it was embedded in the document. And of course, you have the nest keyword that does the exact opposite. Again, if you're querying or working with JSON documents, you have complicated structure, list, object, array. So you have the in keywords or any or every. That's basically to know if that keyword is in any of the value of that list of things. You can do, not sure we have an example here. The a.0, or you could do x.y.z is basically my document.y field.z subfield. You know, you can use any subfield or inner subfield of that document. Everything is available here, so that's quite nice. So if I keep on talking about JSON types, you have string, you have objects, booleans, null, arrays, and there's one thing extremely important, which is the missing type. Why is that important? Because we handle null, so you could check if null. That would give you an appropriate answer, but in a traditional SQL store, because you have your column and your types, so it's not like something could be missing from a document. Here, of course, I'm using a JSON store, I mean JSON documents. So a field could be missing from a document that could indicate something about that document. So you need to have the missing keyword, or is missing. So we've added that too. You have some stuff to use dates, I mean, many interesting things. You can try everything. You can download Couchbase. You can go on. We have a nice online tutorial that you can try now because it's query.couchbase.com. It's an online thing to learn. Well, I mean, it's to learn SQL, so it's not really that important. The first 20 steps are just SQL, and then you have some interesting thing that you can do based on the fact that we're storing JSON documents. So you should definitely check this out. I have now 10 minutes for questions. If there is no question, I can show you some fancy reactive Java code that we used on the Java SDKs, because I'm at a Java conference, so I feel like I should show you some Java code. But I will first take some questions if you have some. Yes?
About it's called NoSQL?
Nickel. It's pronounced nickel. Alors en français, c'est nickel. In English, it's nickel, just like a nickel, and it's written N1QL. And I have no idea why they chosen that name, but that's the name.
So
It's SQL for documents or SQL for JSON.
do you think that all databases will catch up and provide exactly the same interface?
Yes, I think every database will merge from a functional perspective. There's a lot of people that talk about polyglot persistency. It's about how you store your documents. I think everybody's going to use a key value documents kind of store, and then it's going to be about polyglot querying sort of things. People will allow you to query your document store using something like Nickel, using Graph, using time series queries, all this kind of stuff. I think that's where the world is heading. Everybody is going to allow you to do very simple querying and various type of querying based on one kind of document,
Okay.
one kind of store, sorry.
Because
Yes, I'm expecting them to catch up.
Yes, because in the Hadoop world, when we use SQL, for example,
Yeah.
SQL, some capabilities already exist with Explode, for example,
Yeah.
which is something at Nest.
Mm.
Maybe that may merge.
So I don't know if that's going to merge from the Couchbase world. I know we have a Hadoop plugin that allows you to remove all the, not remove, but transfer some data from Couchbase to Hadoop or from Spark or anything. So you can still use that. The goal of something like Nickel is to make sure that we cover those 80% of use cases. You know, we want to be as wide as possible. We don't want to do everything because Spark does it quite well, or Hadoop has something that it does quite well, or Storm or anything. We just want to be able to, just with a simple single deployment of Couchbase, have a lot of things already. We're also working on something called Couchbase full text server. So it's going to be full text search, just like Elastic, but inside Couchbase. That's going to be great. So I think more and more databases are going to converge in that. So it's all about this 80%. And then if you have some corner case, like Graph or time series, then you could use Neo4j because it's a great product, or you could use Cassandra because it's a great product too. Don't use Mongo, it's not a good product. To go back to that, Mongo and Couchbase are seen as document database. So if you want to choose, you can choose several NoSQL databases, right? Because Cassandra is a different model than Neo4j, which is a different model than Couchbase. But Couchbase and Mongo are the same model, so you should probably choose one of the two.
Another question. Again, can you explain the range queries?
A range query, in which sense? In views, in Nickel, or?
Like you talk about hash and indexing, like that was really fast to actually don't use run moving and so on with hash, like key based on hash. And you talk about range queries, how the two are combined.
So if you want to do a query, you forget about the key value stuff. I mean a range query. I mean you could model a range query based on the counter, and I want every user between value 100 and 200 to do pagination, which is sort of a range query. And if you want to do a date range query based on nothing that's in the key, you need to create a proper index.
Okay.
All right. So when you do that index, I should probably go back a bit and show you an example. I think I have an example somewhere. Yay. That thing here. We make sure that the document is of a field called birthday, and birthday is probably a date. So when we create our view, and that's nothing about Nickel as the materialized view here, we emit a new entry in our index. We use the date2array function to split our date into an array, which is year, month, day, hours, minute if you have them, millisecond if you have them, And based on that array, once you have that index, you could do a range queries and asking for every document that dates are between, if you do just one level this year and this year, if you do two levels this year and this month, and this year and this month. I mean, it's just a normal query, so I'm not sure I get the question right.
It's just like you have to ask all servers about the.
So when you build an index like this, and your data is sharded into several nodes, the index is also sharded. That MapReduce function runs on each and every node of your cluster. So each time you add a new mutation document, the MapReduce function will pass that through the document and then maybe or not add an entry. So your index is sharded, so when you do a range query, again, it's a distributed query, so it's going to choose one node, scatter everything on every node, ask on every node to do that range, and then gather everything back and send you the result. Since we have the end on the sharding is done automatically based on the key and the hashing algorithm we have. That data, those people that have the birthday next to each other are not necessarily going to be stored next to each other. This is something you can do in Cassandra, where you have your hands on the cluster key, so you can make sure that when you write something, you can write it next to something else. I'm not a Cassandra expert. Basically, that's why Cassandra is a good fit for time series, because you know that you can store things next to each other, and when you do a range query, you're going to just ask one, maybe one node, or maybe just one sector in the disk, or something like this. Since we do sharding automatically, we don't know, so we'll have to ask everything, every node, and then retrieve the document, the result, and then send the results. Now, if you use NoSQL, one of the cool things we've introduced with NoSQL is something that we call multidimensional scaling. Ooh. What does that mean is you have now 3 types of services in Couchbase. You have the data service, which is just the key value and the views that we've seen here. And you can add on the side another node, it's a query node, and another node that's called the index node. So an index node, we have the whole index at just one place. So you don't need to scatter everything anymore. When you run that query by the query service, it's going to ask the index service, and the index is on one machine, so you don't have to scatter anymore, which is great if you do time series with Couchbase. You don't have, it's a pretty new thing for Couchbase, so I'm not going to tell you it's going to be faster or easier or better than other solution. I can tell you that we're working on it, and it's better than it used to be, based on that. So you could probably check it out. It's cool. You can scale out, add more node with data parts, and then the query service, which is pretty hungry in CPU, you could scale it up. Like you have one node that does query, but you can add more and more and more CPU instead of splitting index or query node. So you can scale that way or that way, which is quite cool. No more question? Huh. I mean, I can answer a question after. I'm only leaving in an hour, so I can just show you one quick thing, just to show you just a bit of Java code, and hopefully you'll want to try it. Have any one of you heard about reactive Java? Some of you, few of you. That's sad. Reactive Java. I mean, have you read the Reactive Manifesto? It's a great website that tell you what's reactive all about. And when you are reactive, you need to be reactive from ground to bottom to top. So each piece of your architecture should be reactive, and we've embraced that, and our SDK is fully reactive, which from a coder perspective means non-blocking and asynchronous, among other stuff. So what does that mean when you use an asynchronous non-blocking API, sorry? If you are used to map reuse and stuff like this, you probably recognize flat map. No? Yes? Maybe? I don't know. All right. So what we're going to do is do a query, and limit it to 10. We're going to open a connection to the server, and the data is going to come as it goes. We're not going to wait. The server is not going to wait to have the answer and send us a huge byte array. It's going to wait, and we'll get all the data as it comes. And for all the data, I'm going to flat map that response. We've been creating another asynchronous stream. You probably have, maybe you've heard of reactive streams, bit like the same thing. In the Java 8, you have streams. And it allows you to do observable streams. And then based on that, when you have one object into the stream that comes up, you can decide to do something. Here I'm just printing the result for each new document. That might seem like something useless, but you can actually do some very nice stuff, like this. I think that's one of the examples. That's not the one I was looking for. Let me see. Yeah, error handling, that's a nice example. Yes. So let's say you're using just the key value part. I'm just getting a document with key is beer. And if I have an error, like the beer document doesn't exist because maybe the node it was active, the document was on one node, and since Couchbase is a replicated distributed data store, there's another node that has a replicate version of the document. if the original node falls down for some reason because Amazon decided to turn off your machine, it happens, we've seen that before. What you can do is, okay, I have an error. I have a nice operator called onErrorResumeNext, which allow me to trigger another operation, which is basically ask for a replicate, of the document. So it allows you to manage retry and errors on the same stream pretty easily. You would have to, if not, you would have to all do the threading yourself, the asynchronous stuff yourself, the callback yourself, the error check yourself. So it's stream from a database perspective are a very useful abstraction, and that's what RxJava or Java Streams gives you. We've chosen RxJava because it's more widespread than Reactive Stream. Reactive Stream is very much of a Java thing. RxJava is when Rx Reactive is used. Originally, it comes from .NET world. It's used in Android, Node.js, and there's many other implementation. So that's one of the reasons why we've chosen that. With that, it's I think time for me to wrap this up. So thank you very much for joining this talk. Thank you.